Okay, so let's do N13. These are proofs, and what we're going to be able to prove here is some of the facts that we were using. So that should be fun to see why some of those facts that we were using are true. And a lot of it has to do with going back to triangles. So we'll see that. Okay, so number one here says PQ is parallel to RS. Let's go ahead and mark that. PQ is parallel to RS. And they didn't state it at the top, but they're showing us with the markings that QP is congruent to RS in length. Okay, it says complete the proof that PRQ is congruent to RPS. PRQ, which is this angle right here, is congruent to RPS. Okay, that's what we want to prove. I'm going to erase that because I had already made the mistake of using those when I was trying to identify if it was side angle side or whatever. So I'm just going to leave that out. But that's what we were trying to prove. Okay, so the first two lines are given and given. One of them was given as words and the other one was given in the diagram. Line 3 says angle PRS, which is this angle in green right here, is congruent to QPR, which is this angle right here. And they're saying that's because of the alternate interior angles theorem. Yes, so remember they told us that QP is parallel to RS. That makes this a transversal. And that makes these two angles alternate interior angles. Alternate interior angles. So that's true. Okay, PR is congruent to PR. That's line 4. That's because that's what we call the reflexive property of congruence. Line 5 is a statement about the triangles. They're saying that the two triangles, so let me erase some of this transversal stuff that I had. They're saying that, let me erase the parallelism. Okay. So triangle, oh sorry, I forgot to mark this. This was line 4, that RP is congruent to itself. Okay, so they're saying PQR is this triangle on the left, they're saying is congruent to this triangle on the right. And we have to determine how they know that, okay? Well, that's going to be one of our triangle congruence shortcuts. So if we know that this side, this angle, and this side are congruent to this side, this angle, and this side, then the two triangles are congruent by side angle side. That's a side angle side. Okay. Line 6 goes on to say that PRQ, which is this angle right here, let's do it in a different color. Let's do black. PRQ is the same as RPS. Okay. Well, on the previous line, on line 5, we already said that the triangles are completely congruent. Therefore, this individual angle here, which correspond to each other, those are going to be congruent also, since the whole triangle is congruent. So that's what we call CPCTC, which, if you don't remember, that stands for sorry, even I forgot what it was. Corresponding parts of congruent triangles are congruent. All right, so let's plug that in and make sure we're right. SAS and CPCTC. SAS, CPCTC, submit. Okay. Next one. The next one says, assume WX is congruent to VW. WX is congruent to VW. And that UX is congruent to UV. So this is congruent to this. Oh, so this is a kite. And it wants us to prove that UWX is congruent to UWV. Okay, so I don't remember using this fact in any of the other sections that we did to solve any problems. But it seems like this diagonal here, they're saying it bisects angle W into those two smaller halves, red half angles. Okay, so let's look at the proof. Line 1 was given, line 2 was given. Line 3 is the reflexive property of congruence. That makes sense. UW is congruent to UW. That's just saying that this is congruent to itself. Okay, the next line, line 4, is claiming that the two triangles are congruent. So this triangle on the left is congruent to this triangle on the right. Okay, so we have to use one of our triangle congruence theorems, like the shortcuts, the side, 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 angle, side, angle, side, angle. Okay, so in this case, we know that this side, and this side of this triangle are congruent to this side, and this side of this triangle, this other triangle. So this is by side, 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 the two triangles are congruent. And then in the last line, line 5, of course, if the two triangles are totally congruent, then of course these individual parts of them are congruent, which is these angles. So these were the two corresponding, these two angles correspond to each other. Notice the W is on the right end, and that's what we're saying, the two angle W's are congruent. So this is CPCTC. Okay, let's plug that in, make sure, side, 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 and CPCTC. Okay. Next one. Okay, so this one says, complete the proof that angle EGH is congruent to FEG. Where are those? EGH is this, and FEG is this. And notice what we have here. Given these markings, the ones that came with the picture, those 4 red marks, this is a parallelogram. So it seems like one of the properties of a parallelogram is that these two angles are congruent to each other. Okay, and probably so are these, but we're not focusing on those. Okay, so let's see how we would prove that. Line 1 and 2 are givens. They're given as markings in the diagram. Line 3 says that EG is congruent to EG. That's because it's literally the same line segment. And that's called the reflexive property of congruence. And then we have side, side. Now, okay, so now they're claiming that the two triangles are congruent to each other by the side, side, side theorem, which is true because we have this side, and this side congruent to this side, and this side. And then the last step is they say that these two angles are congruent, FEG and EGH. and that's because of CP/CTC. If you already know, and again, just to reiterate what CP/CTC is if you already know that the two triangles are completely congruent, then of course any of the little individual parts have to be congruent to each other. And that logic, we call that CP/CTC. Okay. So this says angle PRQ is congruent to angle RPS. Okay, let's write that down. PRQ. This angle is congruent to RPS. RPS is this one. PQ is perpendicular to QR. So what that implies is that this is 90 degrees. Line segment PQ is perpendicular to QR. So that's 90 degrees. Okay. This is looking like a square or rhombus or something. Okay, and then it says PS is perpendicular to RS. PS is over here, RS. So this is 90 degrees. Okay. Certainly looks like a rhombus. It says complete the proof that RS is congruent to PQ. Okay, complete the proof that this is congruent to this. Okay, well, let's erase that before I make the mistake of thinking that's one of the things that are congruent rather than what we have to prove. Okay, so let's go through the proof. Line 1, 2, and 3 are the given information. Line 4 is claiming that Q is congruent to S. That's these two. Well, they're both 90 degrees. So that's all right angles are congruent. Okay. The next thing we're checking is, or the next thing they're claiming is that PR is congruent to PR. That's true because it's congruent to itself. And I marked it up here in blue. That's called the reflexive property of congruence. And then in step 6, they go on to claim that the two triangles are congruent. Okay, so that probably means we need to invoke one of our triangle congruence theorems. So we have this angle, and this side being congruent to this angle, and this side. So that is angle, angle, side. If we just focus in on one of these triangles, it looks like this angle, and this side. It's angle, angle, side. Okay, so this is angle, angle, side. And then the last step is already given to us. It's that the opposite sides are parallel, and that's because of CP/CTC. Okay, so let's plug in AAS. Let's make sure we got it. Okay. All right, so VW is parallel to UX, and UV is parallel to WX. Okay, so notice that those are the conditions describing a parallelogram. So VW and UX, and then UV and WX. So we know we have a parallelogram on our hands. And apparently, when you have parallelograms, VW and UX, let's erase some of this parallel stuff. Apparently VW is congruent to UX. Yeah, so this proof is interesting because this is a proof. Remember what we said about parallelograms. Not only are opposite sides parallel, but we also said that they're congruent to each other. Opposite sides are congruent. Well, this proof is using one of those facts to prove the other one. So this is how you can figure out that parallelograms actually have opposite sides congruent. So, all right. Okay, so let's look at the proof. So the first couple steps are given information. Again, these two imply that you're looking at a parallelogram. It's not necessary to know that for this proof, but since in these videos I had been using all of these random properties about parallelograms and stuff, it's nice to realize that what we're about to do here is a proof regarding one of those facts about parallelograms. Okay. So line 3 says angle UWV is congruent to WUX. So UWV, which is this angle right here, is congruent to WUX, which is this angle here. Okay, line 4, oh sorry, what's the reason for that? The reason they say is alternate interior angles. Yeah, that makes sense because they told us that this line was parallel to this line, and then this is a transversal. And those are alternate interior angles. So they have to be congruent to each other. Okay, let's erase that. Line 4 says VUW is congruent to UWX. It's like half the battle is just identifying these angles. So VUW is this, and UWX is this one. They're saying that those two are congruent. Okay, well those two are made up of this side and then these sides. And notice that that's a transversal with two parallel lines. And so that's for the same reason as line 3. They're alternate interior angles. The two green angles are alternate interior angles. So this is alternate interior angles theorem. Okay, line 5 says that UW is congruent to UW. Let's erase some of this stuff. Yes, that's because it's literally the same line segment. UW is congruent to itself. So that's reflexive property of congruence. Okay, and then notice the last two lines, how they conclude that those two opposite sides are congruent. They use ASA to say that the two triangles are congruent. So triangle 1 on the left here is congruent to triangle 2. And then, of course, the individual parts have to be congruent to each other. Yeah, so basically breaking up these quadrilaterals into a couple of triangles to do all these proofs, because we know so much about triangles already. Okay. So let's just plug that in, make sure we're right. Alternate interior angles and reflexive. Congruence. The submit button does not like me. Okay, finally. I have to push it 5 times.